Not yet.
Not yet. Dineo, have you started the session on your side? Hey.
Yes, I have. Thank you. Good evening, everyone. Welcome to one of our blast sessions. You will remember that we have sessions that are dedicated to areas that you as the students have found to be particularly problematic. And today we're looking at developing a sampling plan, both for quantitative and qualitative research. So basically, you will know that whenever you're carrying out research, you're expected to have subjects or participants or respondents that you choose to engage with as part of your study. The number, the identity, and all the characteristics of the items that you choose or the humans that you choose are all designed or determined through very formal sampling strategies. So today's session is going to look at how you as a student go about thinking through your own sampling requirements for your study. My name is Tennyson Mukuchini. I'm Professor Tennyson Mukuchini. I am the project leader for this project and also happen to be the acting executive dean for the College of Graduate Studies. So as always, I will turn off the screen in a short while so that I can take my face off and walk you through the presentation. Now, some basic administrative things. Remember, with each of the sessions that we present to you, you can access them after the fact by coming for the recording through this platform or going to the session's invitation that we sent to you and clicking on there, and you should be able to get through. So as promised, I will now take my face off and get into the subject matter for the evening. Right. Okay. I've turned off the camera now, so we can move on to the actual presentation. Right. Once again, we are going to look at the strategies that you go through to develop a sampling plan, both for quantitative and qualitative research. The first question, of course, that people will ask is, why not mixed methods research? And the simple answer is this. Mixed methods research is a combination of a quantitative aspect and a qualitative aspect. So essentially in mixed methods research, you are sampling, or your sampling strategies are a combination of the quantitative methods and a combination of qualitative methods. So if I teach you those two, it is not difficult to then figure out what would happen with mixed methods research. In mixed methods research, if you will have an element of the study that is qualitative, so that element we will subject to qualitative sampling approaches. You have an element that is quantitative, so that element you will subject to quantitative strategies. So essentially you're learning a 3-in-2 here. You're learning about quantitative, you're learning about qualitative, and you're learning, you can, by implication, you can work out what mixed methods research would look like. Now, a very brief look into what the session will cover, what we aim to cover. So I want to introduce you to some key concepts around sampling. And the reason we do this is sampling, like many parts of research, have a specific language that they utilize. And unless you understand that language, you can't understand the teachings of it. You can't specifically say the right things when you're talking about your sampling. And of course, you mix up things in ways where you are referring to something in a way that means something different. Then the next thing is we're going to look at the two broad groups of sampling that exist. The first being probability sampling, then the next being non-probability sampling. In basic terms, and we'll revisit it, but in basic terms, probability sampling is the sampling that looks at choosing what you choose using mathematical approaches, probability-based approaches, statistical approaches. And that, of course, if you think about it, must refer to quantitative sampling. Then non-probability sampling is where you're sampling things not because of the numbers or the mathematical issues. You're sampling them on the basis of them possessing characteristics that have nothing to do with probability, but more to do with the phenomena that is being studied. That is non-probability sampling. Then, of course, I will walk you through some of the issues you need to be aware of when you plan for your sampling, issues to do with bias, how you deal with, understand the concept of representativeness, and of course, issues to do with what we refer to when we say ethical sampling. Now, very quickly, I will then talk to you about the steps that are implied in qualitative and quantitative sampling. So if you're going to sample, these are the steps you follow, something like that. And at the end, I end with what I have called a student sampling workshop idea. But really what I'm saying is I'm posing some questions for you on the premise that you can use those questions to help you to develop a sampling strategy. Now, with this session, as you know, we attract people at very different stages of their master's and doctoral work, or honors work for that matter. And because of that, someone may listen to this and go, oh, how does sampling relate to me when I'm now writing my chapters? Or how does sampling relate to me when I've passed it and I'm towards the end? And the basic answer is this. Until your actual work is submitted, the corrective opportunities are not gone, hey? So if you find out something that betters your introduction and you're writing your final chapter, you go back to your introduction and you better it. So similarly, whenever I do this session, there are students who have far exceeded the stage of sampling, but they hear things. They hear things that we speak about which tell them that, oh, I could go back and integrate this in particular ways. So that is important, that we don't limit the applicability of this to just those who are about to make sampling decisions. This applies to everybody. Those of you who have experienced my sessions before will know that I always start with defining whatever concept is central to the session, because once you get the right definition, all the behaviors that are expected in relation to that activity become very clear from the definition. So much like the other concepts that we have defined before, sampling is seen as a process of selecting a portion of the population to represent the entire population so that inferences about the population can be made. So what you're saying when you talk about sampling is it's the process of us choosing a small group of subjects, a small group of respondents, a small group of participants. And this group are being chosen so that they allow us to represent the entire population. So what you're saying is that sampling is about you choosing 4 or 5 people, a few things, a portion of what is fully there, and using that portion to give you a fairly sound understanding of the portion that was not included. So basically, you do, if say we have a population of 100 and then your sample is 20, you would choose the 20 so you can better understand how the other 80 that you did not include would respond or behave. So that is what sampling is about. But remember now, you realize that in that definition, there's a reference to portion. I mention this because oftentimes people come back to me to ask whether it's appropriate or in fact advisable to have a sample that's made up of 100% of the population. And the answer is, according to the principles of sampling, sampling is meant to be an activity you do to get to the truth by being frugal with resources, not wasting resources. So the minute we don't do sampling and you suddenly are applying an understanding of 100% of that population or whatever, then it means that you are being wasteful as far as research is concerned. And those of you who have listened to my earlier sessions, you would have come across this concept in research that they call parsimony. It's rule absolute. It's a rule that basically stipulates that in research, number one aspiration is to make sure that you use the least required resources to achieve whatever you need to achieve. So don't you don't get anything from a research point of view. You don't get any benefit by oversubscribing when you can understand that same thing with investing less resource in it. Now, as I say, with sampling, it's an interesting thing because a lot of it is automated, a lot of it is simple, but it's all based on a basic understanding of terms at the point of departure. And what I've done here is to identify some of the key terms that people talk about so that we can make sure that the language you use is consistent with the language that is used in sampling spaces and so forth. So the first term, and the first term that we need to clarify is this term where in sampling, if people use the word population, we are referring to the entire sum total aggregate of cases in which the researcher is interested. So what we're basically saying is that if you're doing a study and your study is on students, or you're doing a study and your study is on mechanics, you're doing a study and your study is on children, all the children that fit the category of children are the population that you're interested in. But in that population, someone may actually say, look, I'm interested in children, but I'm interested in male children, and I'm interested in male children who are accessible. That then becomes the accessible or source population. So what you're saying is that the aggregate of cases that meet your designated inclusion criteria and are also accessible to you as study subjects. So if you are interested in students, but in that those students become the population, but if you're interested in students in the final year, then that group of people become what we call the target population, because it is the group that you're going to study, so you can draw generalizations. But now that you know what the target group is, there may in that group be people who meet their criteria, but they are not reachable. So they're inaccessible, but there are those that meet the criteria and can be vouched and verified as being accessible. So they become your accessible or source population. So essentially, the word population alone refers to the entire group that you're interested in. So in my example, students. The word accessible or source population refers to that group. Out of the population, it's the people who meet your designated inclusion criteria. So if you're interested in young men, then it becomes young men who are your who are your target population, because it is whom you want to generalize about. But in that target population, there are people that are not accessible and those that are. The ones that are accessible, you call them the accessible or source population. The word source is used because it's actually saying that's the place from which I source the actual people that I will now subject to questions or do whatever. Then the last concept or term that's spoken about in sampling is this term that they refer to as the sampling frame. Now, that is defined as the source material or design from which a sample is drawn. In essence, when I say sampling frame, I'm talking about the complete list of that tells you all the details, or that gives you the details of all the members of the population that you wish to study. So say, for example, if you were going to study young males at a university in their fourth year, if you went to the registration records to tell you who's registered or not, and their age and so forth, that would, the registration notes that you access represent the sampling frame. But what happens is not everything as a sampling frame. So if you were interested in the opinions of people who shop at a particular superstore, because you do not have a list, a definitive list of that tells you who shops, who doesn't, how many people shop, that particular study does not have a sampling frame. So a sampling frame has to be that device or source material from which you can draw a sample as the day stands. Now, so we know population, we know accessible or source population, we know target population, we know sampling frame. These are terms that become particularly important when you're writing your proposal, writing your dissertation, writing your thesis. Because now when you say to me the population was this, I understand it to exclusively mean that you are talking about all the people who are in the category or group that you're interested in. And similarly, when you say or utilize any of the other words there, I understand it the way I've described it to you and not the way you might have known it. And so it's important that we get this right. Now, of course, there are particular standout issues or characteristics that researchers pick out as characteristics that they want to really mess with and deal with, or the characteristics they want to not have to deal with. So if you were doing a study that's studying final year students, you might say you only want final year students who've actually been coming to class. The ones who have not come to class are not excluded, are not included. So that becomes a form of criteria that you're using to decide what's included and what is not included. And the criteria that you use to decide what will be included we refer to as inclusion criteria. Then, of course, the criteria that you use to talk about what is not included is called the exclusion criteria. And any sampling plan must have some mention of these inclusion and exclusion criteria. And sometimes you might include people by virtue of the fact that it's too costly to research them. So if you're researching students and There were some that were in very remote areas and you needed to go and see them and you couldn't understand, you couldn't get there because of resources or costs. You may actually use that to predict that I would rather not speak to this person. Often the typical cost or resource limitation that we hear about is decisions that are made to exclude non-English speaking participants. So in essence, you will see that people will say, I'm doing this study, but anyone who does not speak English will not be included. And the real reason behind it is I'm a student and I can't afford a translator. That, or the concept I'm studying does not translate across to any other language outside of English. Then, of course, there are things to do with feasibility. There may be people or participants that are available, but too far away for it to be feasible for you to access them. Then the issue of individual ability to participate. So say, for example, you were interested in victims of a particular crime. But then there were some people who met your criteria, but as a result of them being victims, they might have lost their ability to speak, or they are close to death's door. You would decide that individually it is improper for them to participate. So that then becomes your exclusion criteria. Now, then there are some inclusions and exclusions that are to do with the design that you've chosen. So if you choose a design that specifies that we are only interested in studying this particular group and nothing else, then that design might force you to have a homogeneous inclusion criteria at the expense of something that's heterogeneous. So, and when I say heterogeneous, I'm talking about some designs, particularly qualitative ones, thrive on the idea that every participant is different. So the richness of the sample is because everyone is different. While by contrast, people who do probability, mathematical, and all that quantitative sampling are interested in having a group that bear the same characteristics, so that when they test whatever intervention they're testing, they can reliably say we tested it on the same person and these are the results we got, or the same type of person. Then, of course, things like there are some things that might affect your ability to generalize. There are some things that you are excluding because actually they mess up the concept that you are trying to study in some shape or form. So all those things become the subject of the reasons why you would exclude particular sample representatives from a group, because they have one of these things. But you must write your own inclusion and exclusion criteria. What I've done here is just offered you some ideas of typical ones that you would meet. Now, as I've said, there are two types, broad types of sampling: probability, which is mathematical; non-probability, which is more characteristic based rather than anything to do with maths. So in quantitative research, where numbers are everything, the gold standard of sampling is probability sampling. And to reach that ability for it to be golden, there's a strong idea that randomized sampling or random sampling is the gold standard. And it is the gold standard because it allows you to get greater representation, so you get a sense of confidence that the group you are studying are indeed representative of the bigger group from which you have drawn them. Then, of course, probability sampling, by virtue of it being mathematical, it can actually tell people before they've even been selected or left out what probability or chance of being included they have. While by contrast, non-probability sampling is quite different. So of course, qualitative anything is looked down by the quantitative world because it is the opposite of. So it's a little bit like supporting two teams that don't get on or see the world differently. One of the things is that the one team will always have a low opinion of how the other team operates. So, and in this world, probability sampling was the gold standard of sampling for many, many years. And there's still kind of a war between that type of sampling and non-probability sampling. Then, of course, you notice I introduced the concept of bias. Bias is a form of limitation that we meet in sampling. That limitation is broadly to do with the acceptance that when people choose or select candidates, subjects for their studies, they may actually have embedded preferences that they end up utilizing to decide who they want. So sometimes you may decide that, look, you want to sample workers at a particular place, but if you decide to do the sampling in the morning, you might by chance actually bias your findings towards those people who like to work in the morning as opposed to the afternoon shift. And that whole non-probability sense of it, or your sampling approach then becomes subjected to questions about how biased was it or how biased is it not. And of course, non-probability sampling, because it is less about numbers, but more about judgments that people make, it's more likely to be bias-ridden. Of course, items in the non-probability world are not mathematically determined, so non-random sampling or selection is the order of the day. And of course, because we're selecting people essentially by virtue of whether the characteristics they bear are similar to what we're studying, that then becomes how we include people. But you cannot, in a non-probability study, be able to say with any confidence before your sampling process begins that you can tell that that person has a 5% chance of being in, the other has a 7. Non-probability sampling does not offer you the power to determine the likelihood of someone or some subject being included. So it's kind of blind in terms of mathematical prediction. So this is the introductory material around sampling. So now I spoke about the steps, and I want you to just very quickly consider this. And it's the steps for sampling, both in qualitative research and quantitative research, are pretty much the same. It's the idea of first defining or understand. First of all, you have to figure out, tell us what the population is. Remember, now I'm using this word in the way I defined it earlier. So in the sampling world, you begin by telling us the population. What is the aggregate group that you're going to draw whatever you're drawing from? Then from that, you then tell people that out of this group, the ones that I'm targeting are this group. So you define your targeting group. Then you say from this group that I'm targeting, I need to know who is accessible, who is not, who is placed in such a way that I can't use them, and who is placed in such a way that I can use them. Then, of course, in that process, there's the defining of the sampling frame. Now, this step, the sampling frame determination, is a very curious step because it can happen anywhere. If you know who you're targeting, nothing stops you from finding out, getting a list, so you can better know who that out of your targeting people, out of the group that you're targeting, they come from a list that tells you how many, who else is in the same as your target group. But people talk about this sampling frame idea as something you can do right at the beginning. You can do it when you know a little bit about your accessible population, so you get a list of them and so forth, but it's there. Then, of course, in quantitative research, you then randomly select the people you want. So you apply some mathematical approach to work out who you want. In qualitative research, you do the same, you just don't use mathematical approaches. Then when you know who you want, you tell us now the rules of who stays in and who stays out from the people that you want. And that is what the inclusion and exclusion criteria are. Then, of course, in quantitative research, there is this idea that you are studying cause and effect, basically relationships between something being done and an outcome happening. So in sampling, you sample and you develop an understanding of the numbers that you are going to access. Then you must decide, depending on the type of quantitative research you do, half of your people might be in a group that receives no intervention. Then the other half become the group who do get the intervention. So you need to apply your random assignment to the experimental group. And that's the ones who get your the ones who will get your intervention. Then the control group are the ones who meet the criteria to be included, but you're not exposing them to that stimulus because you want to check how is it for the ones who are included versus how it would be for the ones who are not included. So these are the steps. Not difficult at all. You go from the big population and you sift down until you're stuck with the group of people that you really, really want. Now, remember I showed you the quantitative strategy. The qualitative strategy is not much different, quite similar. First step, you tell the world, or you clarify in your head, what is it that makes a client or a participant ideal to me? Because that is what defines the population you'll be interested in. Then from that, you decide, so I know what makes them ideal. Let me figure out who I can find, who I can't find. That's the next step. After that, you determine, you make a decision about where you're going to find these people. So you've identified who you're going to consider to be accessible. What are the characteristics of someone who becomes a source population measure? Then from that you say, okay, this is what they look. Let me figure out now where I will be to recruit them. And once, of course, they're recruited, you approach and invite them. And when they come, you obtain consent once again. So, but I know the way that this is described suggests that the two approaches are different. The answer is not really, but they emphasize different things. So you'll realize that the first strategy for quantitative research emphasized specific identification of the population, random selection, and so forth. But qualitative research sampling is more interested in making sure that you have the right people, you are asking them questions in the right way, and that you're treating them right. So immediately, the strategies are quite separate in that one is about figures, the other is about narrated experiences. Now, so I've told you about these things, and I want to now show you that in this world, I told you that there's probability sampling, there's non-probability sampling. In basic terms, probability sampling is the mathematical version, the one where we seek to do things mathematically in a way that allows you to predict with reasonable certainty how likely participant A is going to be to end up being included or not, mathematically. And in this probability sampling world, there are types. There are many types. And what I do is I share with you the most common types that you are likely to meet given the level of study that you're at and the nature of research that we do in scholarly research, in academic research. And the examples that I'll walk you through are four of them. All of them are examples of probability sampling. Sampling that is based on mathematical calculation, mathematical formulation. So the first one is simple random sampling, followed by stratified random sampling. Then I'll talk you through cluster sampling, and finally systematic sampling. All these methods, you may forget them. You may forget some of it when you leave this room, but once you've heard it once and you revisit it, it becomes easier and easier and easier. So the first of these, probability sampling, it is actually, random sampling. And you'll see why I made the mistake. Random sampling is the first, simple random. It is the building block of every form of sampling that happens in the quantitative world. That random sampling really is about randomly identifying something using a mathematical formula to just identify something through randomness. No attempt to correct it or anything. You just randomly apply a formula, you randomly process things. The simplest form of random selection that you might have come across is when people take a raffle and they have tickets in a hat, they just pick them out randomly. If someone told you there was 40 tickets, then each of those tickets has got an equal chance of 1 in 40 of being selected. That is what the mathematical probability and the predictive nature of random, of probability sampling offers. It is the building block of all quantitative sampling approaches. They always have an element of random sampling somewhere. Of course, if when you apply sampling and you do it a randomized way, you will rely a lot on software, you will rely a lot on machinery to determine things. And that machinery, when you use it, it tells you some other information. It tells you that, okay, your random sample is made out of X number of objects, but it also tells you how confident the software was that the groups that your random sample are indeed representative of the bigger group you want to study. And that you may see as a confidence value, where people say, oh, the confidence is 95% or whatever. Yep, that's really literally a mathematical expression of saying, look, mathematically, we strongly believe we're 95% sure that which we've selected for inclusion in this study is indeed the accurate and required item or subject or respondent and so forth. But simple random sampling is just that, where you know you have 200 participants and you want to randomly select them, you find a mechanism to just choose And that's it, simple random sampling. The more sophisticated version of simple random sampling is this stratified random sampling. Stratified random sampling is an initial division of a population into two or more homogeneous subsets or strata. And in basic terms, this is it. If, say, you are interested in students who are in the fourth year, but you recognize that, hey, this university that you're looking at is made up of 30% women, 70% men. And you want that representation to also be reflected in your sample. So you then decide that, look, I will initially divide this population that I have into these two groups that are homogeneous. They're the same, because if I divide them into men or women, the male side will be the same. It will be men only. The female side will be the same. It will be females only. So that's what stratified random sampling is. But remember, your decision about the characteristics of the subsets or the strata have a lot to do with your pre-existing knowledge of the phenomena you are studying. So if, say, I wanted to study how well people respond to a muscle enhancement treatment, I might decide that, look, I believe people respond differently according to age. So I'm going to have strata or subsets that are to do with people's age groups. Then in the age group, you might decide that, hey, yes, there are men of this age, but no, there are people of this age, but the people can themselves perform differently by virtue of another subset, by virtue of gender. So then your strata, your stratification becomes about age. It also becomes about gender, and you can continue to identify other characteristics that you think have an influence on the outcome, or they have an influence on the phenomena that you're studying and the outcomes that come from that. Of course, it's better than random sampling because it's more targeted. If you're studying an institution or a thing that is made up of 80% men and 20% women, you would like your samples to speak that way. So it's much more representative. This method is much more representative than random sampling. Random sampling will just tell you that there are 100 men, there are 100 people. When you select them, there's a 1 in 100 chance that any one of those people will be included. But what random sampling won't do for you is to say, hey, this 100 people is made up of 60 men and 40 women. Let's make sure our sample is also 60% men, 40% women. Random sampling won't do that, but stratified sampling can do that. So in this world of strata, there's two types. There's what they call proportionate strata and disproportionate strata. So when we talk about proportionate strata, we are saying you have decided to categorize and split up the entity you're studying in proportion to the source population. So where you're getting them, if you're getting something from a group that's made up of 90% men, 10% women, and your sample size is 90% men, 10% women, that is a proportionate sample size. But if you decide that your sample size won't have anything with those percentages, but it will include differentiating people by gender, having men and women, but you won't mathematically determine it, that becomes a disproportionate strata. So once you get informed and you're clever and you know what you're doing, when you're describing and talking about sampling, you would ordinarily say, hi, I'm using a stratified disproportionate random sample, then someone knows exactly what you mean. And you then say the strata of interest are gender, height, whatever. So you find that really when you're dealing with sampling, the more you understand about the rules of how you selected things, the better you're able to describe those rules. So you have a much more sophisticated sampling process. Now, cluster sampling is interesting. What it is called, the other name for it best explains what is going on. Some people call it multi-stage sampling. So say, for example, you were interested in prisoners, how prisoners in a prison X behave, or how prisoners in prison behave. And you're doing it in a country X. Someone would say, okay, so the first thing we have to do is we must randomly decide which regions of that country you're going to focus on. So if a country has 7 regions, 9 provinces, and you randomly decide which of them you'll focus on. That's your first random activity, randomization activity. Once you've chosen the provinces, maybe in those provinces there are prisons. So now you have to randomly select which prisons you will look at from within the provinces. And then once you've decided which prison you're going to look at, inside the prison there might be different wards. So you have to randomly select which wards you're going to look at. And then once you're in the wards, you now must randomly select the human beings in that ward. So that multi-stage sampling is actually what they call cluster sampling. You sample one cluster of interest at a time. Of course, this is a less representative way of doing things, but it's actually practical. That if you're going to study things that could be in 10 regions, you must sample those 10 regions. Then if you're going to study things in X place, you can sample until you get to the lowest unit that you're happy about. That is a practical way of being. And this methodology allows that. Of course, and it's quite free. It's quite cheap, I mean, and I say economical because it involves you just sitting and making decisions without standing up or doing anything. So in many ways, it actually has great appeal for students, because when you're doing academic research, you have a whole load of these things. Do you study all the units in the whole country? Do you choose some? Do you select them? How do you select them? And cluster sampling enables that. So far we've spoken about random sampling, stratified sampling, cluster sampling. Then there's this thing they call systematic random sampling. Now, systematic random sampling is used when you're unsure of the sampling frame or the number of people who will be in the population you're studying. So if, say, you were interested in the opinions of people who come to a supermarket in the morning, you don't know beforehand whether the supermarket will have 10 people, 20 people, because different days are different. So in that respect, you can't predict what the sampling frame was. And so you have a sampling frameless entity that you're interested in. Now, what systematic random sampling does is it says, look, we know that this thing you're interested in will have people. We don't know how many there'll be because it depends on who shows up and who doesn't. But what we do know is that we can say, look, for every 4th person that comes your way, make them your target. That system of saying, I will reach out to the nth, 4th, 7th, 10th participant is what systematic random sampling is. The critique is that it's really not mathematical in the same way that others are. There's no formula apart from you just making a decision that, look, out of every, I will only be interested in the fourth person that comes out. The idea with this is, of course, the more subjects or the smaller the intervals are before your subjects, then the more useful this approach is. So if you say, look, I'll question every fourth person, in terms of the ability to really catch where you're going, you probably should have gone with less than fourth person. You say, look, I'll interview every second person. Then that gives you more representativeness. Of course, because many a time the frequency, the nth subject interval, the subject interval that you used is picked almost from someone's head. There have been questions about whether this method really meets the probability status tests that should go with such. So these are the different types. So you can either say my study focused on randomized sampling, your study was stratified sampling, your study was cluster sampling, your study was systematic random sampling. Now, of course, we are able to very quickly say, look, so probability sampling is like this. If you want to choose representativeness, to have the right number of people so that mathematically they give you an indication of what's going on elsewhere, probability sampling is your only approach. It also allows you to calculate how the method of sampling that you used is likely to have an error in it. So if in this sampling error, and these are automated things that you calculate by just inputting some figures into a software, and the software will tell you that, hey, I'm 95% confident that this sample I've given you is correct. And I also can tell you what the error that's likely to have come from my sampling is. All this is not something that is possible to do outside probability sampling. And of course, probability sampling is complex. And sometimes the demands of it, where it tells you that, oh, you've got 700 people in a source population, go and interview 387 of them. That high number is impractical. For all intents and purposes, it's impractical, but it is what has been preached by probability sampling. So it forces people to do things that are non-economical and sometimes impractical. Right, so non-probability sampling is the mirror image. It's the opposite. So people are selected on the basis of non-random methods. We don't use mathematics to select people. Of course, because it's not mathematically determined, what you find from it is less likely to be representative of the wider group that you're studying. So they have lower representativeness. Then the methods of non-probability sampling that I will share with you are quite straightforward. There's one that they call convenience sampling. So literally, non-probability sampling is talking about all the methods of sampling you would use if you're doing a qualitative study. So convenience sampling is one. The next is quota sampling. Then the other is purposive sampling. These are presented in a way where the least robust is the one we talk about first. Convenience, it's the lowest level of sampling. Then the next is a bit better. Then the gold standard in this world is purposive sampling. And then, of course, I will now share with you some of the characteristics of each. I wanted to start up with convenience. Okay, right. it's not there, but let me just talk you through it. Right. So convenience sampling, lowest level of non-probability sampling. This is a method of sampling where you will determine that people meet your criteria of interest, and you'll say, okay, I'm interested in people who drink this type of drink. So you go to a pub and you find everyone who's drinking that drink. Then you say, okay, I will select only those who seem to be interested in talking to me. So your decision to select the people who are interested in you is more to do with your commitment to finding a convenient approach. Easy, but not always scientifically the most sound. And that's what sometimes people call this referral sampling. Some people refer to it as snowballing. And basically what they're saying is that you speak to whoever is willing to speak to you. Then progressively, as you interview more and more people, conveniently they tell you who would be a good interviewee and who would not. So it's they referred you to another convenient alternative without you actually making a decision that this is what my representative requirements or my sampling requirements are. Now, quarter sampling is the next level up. Now, quarter sampling is very much the same as stratified sampling, but stratified sampling, remember, spoke about proportionate sizes. Stratified sampling spoke about it's mathematically driven, hey, stratified sampling. So you are choosing a different subset because mathematically you know that they are represented in certain proportions to each other. Quarter sampling, on the other hand, is you deciding that, look, I am actually going to look at this phenomena that I'm studying, and I think I'm interested in groups that are male. I'm interested in groups by virtue of gender. I'm interested in groups by virtue of age. But I'm not going to separate them according to how they are represented. I will just have some who are women, some who are men, some who are young, some who are old, without really ever thinking, hey, does my source population have this type of representation? So quarter sampling is a non-mathematical version of stratified sampling. Simple. Now, the best form of qualitative sampling is what they call purposive sampling. And purposive sampling sometimes is referred to as judgmental sampling, and where you purposely select subjects who are judged to be typical of the population that you are studying. So you make a judgment that, hey, I am interested in people who have these 5 characteristics, and I am going to choose them because they possess these characteristics that I'm interested in. And the main issue that determines that is, do they meet my requirements for the characteristics I'm interested in? Do they have those things? So that becomes what your purposive sampling is. But purposive sampling is interesting. It has subtypes of purposive sampling. So some things you say, I want people who have the characteristics I'm interested in, but I want them to be spread in a particular way. And the spreading part is what defines the subtypes of purposive sampling. So I'm going to share some of these. Now, remember, with research, a lot of the terminology is easy to figure out because it's a combination of things that you understand. If you understand the foundational principle, then you can work out what is being attended to or attempted. So when people talk about typical case purposive sampling, they are saying that yes, you're going to choose people with the characteristics that you're interested in, but you actually want people who represent an average or very normal response in that category of people you're interested in. So if, say, I was going to be looking at prisoners in a prison, typical case purposive sampling, I would say, look, I want the prisoner who has no trouble, who is quite typical, who's quite average. So I am selecting only the average ones from the average group. That's a typical case purposive sampling. But sometimes people will say, no, I actually want prisoners, but I want those who are extreme cases or deviant cases. So I don't want a prisoner who is the same and does everything. I want those who are extreme because they're extremely good. They're untypical. They're prisoners, but they're so goody two shoes that they don't represent an average prisoner. But I also want those who deviate by virtue of being so bad in prison that they spend all their time in sole confinement. Now, that's extreme or deviant case purposive sampling. Then there's something that people call critical case sampling. So if you were still looking at prisoners, but you had prisoners that had very dramatic prison experiences, either they were imprisoned and they were found to not be guilty, or they were in prison and they killed a prison officer, that makes them very dramatic and very standout. So you then decide that, are you going to choose people by being a typical case? Are you choosing people by virtue of being extreme or deviant? Do you choose people by virtue of them being critical? So those are the typologies. There's one typology that is not here and probably the most common of those typologies, and it's called maximum variation purposive sampling. That's really saying, look, I want to sample people who represent all the different characters that are there. I want the typical case, I want the extreme or deviant case, I want the critical case, I want to vary it up, and that's what maximum variation purposive sampling is. So now if I were to speak to you about your qualitative choices, you would say to me, I am doing a typical case purposive sample, and then immediately the listener will know. Or you say I'm doing a maximum variation purposive sample, everyone know. Say I'm doing a quarter sampling and my quarters are this, everyone will know. I'm doing convenience sampling, everyone will know. So here, this heterogeneous or maximum variation sampling, I've already spoken about. That is kind of the middle of the road, king of all aces type of sampling that people say, look, I want to understand this phenomena, but I want to make sure that I understand it from every potential perspective, from those who have a critical experience of it, those who have a typical case of it, those who are this or that. So I've mentioned maximum variation is you actually seeking to find people who are different within that phenomena you're interested in. So you're interested in heterogeneous existence. But sometimes people will go for a homogeneous sampling approach, where actually you are saying, look, yes, I'm interested in this phenomena, but in that phenomena, there's just one group that strikes me. I'm not choosing them because they're typical. I'm not choosing them because they're deviant. I'm not choosing them because of anything, except that they are just one homogeneous group. and that becomes one form. Then there's another theory sampling approach that is used, but this is very exclusive. When people do grounded theory research, they observe data and they use the data to develop a theory about what's going on. That's literally what grounded theory is. So take, for example, if you were to look at lecturers, people who teach you, and you thought, hey, there's this one lecturer here who's got the it factor there, seem to be the critical thing. Then the others teach, but you have no clue. They kind of seem to be saying the right thing, but somehow they don't have that it factor. And you think, okay, I want to see if I can create a theory to explain what the it factor that I'm talking about is. So you watch many more lecturers and you develop theory upon theory based on the lecturers. But how you chose those lecturers to understand the phenomena becomes a product of theoretical sampling. You are choosing people because they seem to match the theory that is emerging. So it's this type of sampling that when you start to sample, you don't know who you'll sample, but as you progressively understand things, you refine your understanding of who you are most interested in. And that's what theoretical sampling is. So these are all some of the examples. Now, issues to do with sample size. That's where the next story is with all of this. In quantitative research, folks, the story is obvious. It's easy. Sounds difficult, but it's easy. Quantitative research, back in the day, we used to have a sample size determination formula, very complicated, and you enter different characteristics, numbers, then you compute, you add it up, you do whatever, you use textbooks to figure out, and you calculate it. But actually, these days, in quantitative research, you basically use what people refer to as a sample size calculator. So if you went online now and you Googled sample size calculator, a few will come up. One that's often used is called EPI-info, EPI-info. But there are many, yeah? There are many that people use, and it really doesn't matter too much. They all seem to reach the same sort of sample size. And what you do with the sample size calculator is it requires you to know certain information. It requires you to say what your source, the size of your source population, the size of your frame, the size of your accessible population. Then you comment on the confidence you want to have in how confident you want to be that your results are in fact a depiction of what you're studying and not a result of coincidence. And that confidence value that I'm talking about is given usually as a percentage. And if it's higher than 80%, then it means you're really asking for sample sizes that would make you feel confident that you really, really studied what you want to study. Then the other thing is you can also indicate the error, the margin of error that you're willing to tolerate. Do you want to deal with the study where the sample size could be 10% off the mark, 20% off the mark, or whatever? And if you input all those details that I've given you, and you just put it into the calculator, it just comes up with a number. That number is our sample size. Then, more importantly, it then says this number was generated by a formula similar to this. Then it has a formula underneath. So the calculation, the actual calculation of the sample size in quantitative research is primarily to do with how well you know your population. Do you know the size? Do you know who's accessible? Do you know who's this? Do you know who's that? You pop it into a calculator, boom, numbers come out. And what sometimes people do is they will say, look, the sample size calculator has said I need 300 participants. But I know that usually not all the people I select will participate. So I will build in what is called a non-response buffer. And normally people will choose anything from 10 to 20%, where they say, right, the sample size calculator said I should select 400 people, but I'm going to select 440 because I've built in a 10% buffer against non-response. That's what sample sizes look like in quantitative research. In qualitative research, we're not bound by the rules of quantitative randomized fixed numbers. We are bound more by this principle we call data saturation. So in qualitative research, people seek to reach a point of saturation, a point where they feel that the phenomena they're studying has been so well described by their participants that no matter what they ask, everything that they will come across will just be an extension of what they already know. So in essence, when you sample size determine for a qualitative study, you don't normally have a number. All you have is a destination you want to get to, and that destination is a point where you suddenly are querying people and they're saying the same thing. So that destination is data saturation. But where this becomes a problem is, in theory, you should then be able in qualitative research to say, look, I can't tell you what my sample size will be. I'm just going to carry on asking questions until I'm satisfied that I know enough. But because academic research needs you to be a bit more specific than I'll just carry on asking until I can't ask no more, they ask you to give maximum and minimum parameters, maximum and minimum parameters or requirements, which in essence is you saying, look, yes, I'm going to continue collecting data until my data is saying the same thing, but I will make sure that this destination that becomes the end of my inquiry cannot happen when I've interviewed less than 10 people, and I won't let it carry on until I've introduced 30 people. So then in your sample size specification, you can tell us that, hey, this is I'm using maximum variation purposive sampling, and the number of participants that I will choose will be determined by data saturation, which means I will know when to stop when all the answers are saying things that have been provided already. But to protect you, to protect the process, I will not allow data saturation to occur, or I will not recognize data saturation if it occurs at less than 10 participants, and I will not pursue it if it goes beyond 30. So you have placed a minimum requirement and a maximum requirement. And that is what qualitative sample size determination looks like. Not about numbers, more about saturation. So the phenomena you're studying looks like it's attended to. Now, there are some things, and I've just put this on here for the fact that there are factors that normally come up. So people will say, when you are doing sample size determination in quantitative research, there are a few things that you should be aware of. First is this homogeneity of the population. Are you sure that the people that you have said are your group are indeed having the exact same characteristics as the process that you used on them? That's the fact that you are saying, are they actually exactly the same? Because it matters that they're the same for quantitative research, so that you've cleaned out through inclusion and exclusion criteria and left with people who are exactly the same in relation to the phenomena that you're looking at. Then the effect size is to do with, people will say, look, there's a measure that you can do in quantitative research that allows you to determine whether in fact this finding that you're likely to get, how much claim to the bigger picture of the phenomena can it make? How much effect does this claim, this finding that you have in relation to the big thing that you're studying? Will you study this and have it only affect 2 people, really relate to 2 people? Does it relate to a school, the whole population? So there is an interest in that. Then, of course, other factors like cooperation and attrition, you have to have subject leakage factors and calculate them into your study. So essentially what happens here is, as I've said, people sometimes will say I've factored in an additional 10% to just beef up my study sample size because I expect people to refuse to cooperate. I expect them to drop out. Then, of course, if you are going to study one thing about a group, then your initial calculation of the sample can work. But if you're going to study the group, one layer and another layer and all these, you're going to analyze layers in the groups where you literally break one human being into now 10 entities of interest. Then, of course, you must now multiply your potential subjects. So many calculators are not aware of this. They don't take account of the fact that there might be subgroup analysis going on. So it'll give you a number and say, just find 300 people. But if it was aware that each of those 300 people will be subjected to 4 things, then it might not have said find 300 people. It would have said find 1,200 people. But that process of analyzing multi-level analysis is what we call subgroup analysis that happens within the space. Now, folks, I get to a point where we are open to questions, and I will very quickly turn off my presentation and look through this just to be sure that I'm able to see the questions and answers that have been presented. But as I do that, I will now, I think it's safe at this point to turn on the camera, so when I respond to questions, you're looking at me. Right, and I'm going to stop sharing and very quickly, right, let's see, okay, let's see what questions have been asked. Okay, we have a few questions here. So we have offered you the links, and then Anonymous is asking, is it possible to get a sample of previous proposal? Okay, so folks, you have to recalculate your samples afresh all the time. You're not allowed to use sample descriptors that were chosen by others, because the idea is that once you factor in all the differences between the status and environment of your proposal and the environment of yours, there will be extenuating or mitigating circumstances that mean you must change. So the answer essentially is you cannot. Okay, someone was asking, what informs a researcher to choose sampling in a particular topic? Does the topic determine the type of sampling you need to use? So firstly, how you determine whether it's probability or non-probability sampling is an entire function of whether it's a qualitative study or a quantitative study. So that's the first layer that you look at. Then, in that, once you know that is qualitative sampling, for example, or you know that is quantitative sampling, you then need to understand the topic, the target groups you're looking at, to work out that am I best understanding this topic by splitting people up to different subsets, strata, quota? Am I better just letting people focus on or choose? Am I better in letting my choice of participants occur naturally as long as they are in the space that I'm in? Or am I better selecting participants because they're easy to find? Am I better selecting participants because they represent a critical case? Am I better selecting people because they represent a homogeneous group? So those questions guide you in terms of what choice in sampling you end up looking at. Right, okay, so I've been asked to explain the point about saturation and determining saturation in a sample size in a qualitative study. Say, for example, you're interviewing a group of doctors in a public hospital. So say you were interviewing people about what they perceive the worst experience in a hospital was. And you meet one person and they say the worst experience was the doctors hated me, the treatment was terrible, the food was terrible. You meet the next person, they say something else. You meet the next person, they say something else. Then after you've met a few people and they are all saying what has already been said by others, now you are saturated. That is data saturation. When the feedback that you're getting, correct as it is, all that it is doing is confirming what you have already heard from your previous participants. So that is what data saturation looks like. Right, colleagues, or dear students, I am just going to check something to see if we've got any standing questions. Right, okay, yeah, some of the questions are about challenges that people are experiencing in logging on. So basically, that is the process by which you develop a sample plan. Make a decision, is it a qualitative study, is it a mixed method study, is it a quantitative study? Then you progress from that about the choice, about whether you're using a methodology that's non-probability or probability based, and so forth. All right, yeah, okay, I'm just looking here. I think there's one more question. No, I may be wrong. Okay. Right, okay. Yeah, there aren't any more questions. Okay, perfect. So, dear students, thank you very much for attending this blast session. We are at a phase of the program where we'll be running through highlighted areas that individuals want to focus on. And of course, we will share that with you and communicate via email about the next sessions and so forth. But for tonight, the 28th of July, thank you very much for attending the session and good evening.